Hi and welcome back. So in the past video I had given you an example that actually didn't work out quite the way I had wanted it to. I guess I didn't work it out quite right beforehand. What I was trying to show you was that if I round my calculations before I reach the end of all the calculations, so if I don't carry all those estimations that the calculator made when I divide and multiply two numbers together, if I round after each step of the calculation, I could get the wrong answer. And I wanted to show you an example where I actually do end up getting the wrong answer. And I tried to do that in the last video and it didn't work out. So I think I worked this out just before the video, just before I hit record, and I think this should work now. So we've got this expression: 2.1257 divided by 1.36 multiplied by this expression, divide by that expression, multiplied by this, divide by this. And I should have used scientific notation here, but this will be easier to put into the calculator. It's 0.000000658. And you can see how many significant figures is our final answer going to have. So which one of these has the least significant figures? Well, it's a tie, I guess, between this figure and this figure. Because all of these in this figure, these are all leading zeros, right? So we've got 6 leading zeros and only 3 significant figures here. And then we've got no zeros here, and we've got just 3 sig figs. So we are going to report this to 3 sig figs. So let's just go ahead and do this operation now and figure out what our right answer is. So let's go ahead and clear this out, and we have 2.1257 divided by 1.36 multiplied by 0.002598 divided by 100.5 multiplied by 212.8 and then divided by 0.000000. That's 6 zeros, right? 1, 2, 3, 4, 5, 6. Yep, 658. And that gives us 13,067. And remember, we've only got 3 significant figures here, so we're going to do, and this is the right way that we're doing it now, we put in all of this information, and now that we're at the end of the calculation, we're going to do the rounding. We've got 3 significant figures, so what should this ultimately be? Well, it should be 13,100, right? Because we're going to round that 6 up, so it'll be 13,100 is going to be, let me write that 0 looks too much like a 6, 100. So that's going to be our correct answer. And what's the way that we should write this in scientific notation? Well, it's going to be, and this will give us the unambiguous 3 significant figures, it would be 1.31 times 10 raised to the, and let's count the decimal places, we've got 1, 2, 3, 4, so times 10 to the 4th. So this right here, this is the correct answer. This is what this expression actually comes out to. So now let's go through this, and at each individual stage, I'm going to round after every single operation. And let's see if we can still get this correct answer. So now I'm going to get the calculator out. So we have 2.1257 divided by 1.36. And that gives us this. But remember, I've only got 3 significant figures for this operation. So we had 5 up here on the top, but only 3 on the bottom. So I'm going to start out, I'm just going to round this. So I'm just going to say that this is 1.56. I'll even write that down. So I'm going to round this. So this in orange is just going to be 1.56. And this is what I'm going to use to plug into this blue expression right here. So I'll go back to the calculator. So I say 1.56. So I dump all those extra decimal places now. So I have 1.56 times 0.002598, and that gives me this expression. But now let's say I wanted to round again, and remember I had 4 sig figs here. I've got 3 here. So let's round to 3. So we have 0.00405. So clear this, and I'm just going to dump all of these extra decimal places. So clear 0.00405. Now we're going to divide by 100.5, and again we get a whole lot of extra resolution, I guess. And so now I'm going to, once again, we're still carrying 3 significant figures, so let's round again. So we've got 0.0000402, and then that's a 9, so we would round this up to, write this in blue. So this would be, I think it was 4 zeros, 403. Double check that. So we've got 1, 2, 3, 4, 403. Yep, so that's what this, so after we've reached this blue stage of the expression, this is what we would have, is 0.403. And now let's plug this into our final expression. So now we're going to take 0.0000403 multiplied by 212.8. That gives us this expression. And now let's round this again. So we've got 0.008575. So we round up to 0.858. So we say 0.00858. And last step, we're going to divide by this number. So divide by 0.000000658. And that gives us 13,039. So now you can see, what are we going to do with this? Well, we're not going to round up. So what's our answer going to be? Our final answer, if we did all of that rounding, and hopefully you can also see all of that extra work, it's going to be 13,000. And if we represented this in scientific notation, so we could have 3 significant figures, we would say 1.30 times 10 to the 4th. And so hopefully you can see that because we rounded at each individual step, we ended up getting the wrong answer. So this is kind of a source for, particularly in the first couple of weeks of a chemistry course, this could really be, a source of lost test points. I know I definitely lost a couple of points for problems like this in the first week of chemistry. So you could imagine if you had an operation, if we had an operation like this, and imagine it was a multiple choice exam. Like even imagine we had, okay, so choice A, let's say it's our right answer. Let's say it's 1.31 times 10 to the 4th. So that's choice A. And then choice B, let's say it's actually 1.3 times 10 to the 4th. And then choice C is going to be 1.30 times 10 to the 4th. And then let's say for choice D we just had maybe some, I don't know, 2.57 times 10 to the 8th. Let's say we had some crazy number there. So if we, hopefully you can see that if we went through and we rounded at each individual step, we would end up getting this. We would end up getting, okay, there we go. Sorry, my computer freaked out for a second. We would end up getting this. We would end up getting 13,000 and no hundreds. But the right answer is 13,100. So the right answer is answer A. But if we rounded at each individual step, we would have gotten answer C, and we would have been wrong. And and also you can see why would answer B not be right? Well, answer B wouldn't be right for this because it only has 2 significant figures. So anyway, hopefully this gives you a little bit of hopefully this will give you a little bit of help surviving at least the first couple of weeks of chemistry, because I can imagine if you're going to be dealing with sig figs in your chemistry course, you'll probably have like one little mini quiz or something like that on significant figures. So that, one more time, I can't say it enough in this video, don't round until you reach the end of all of your calculations. So don't round in the center. And kind of as an addendum to that, I'll also say this. Try, and actually I'm not even going to say try, I'm going to say do combine all of your calculations. You want to have calculations in chemistry that, like we had in this example, it's just a string of multiplication and division. We want to have these big long things where we have a whole bunch of information where we say, okay, if we have 1.078 grams, and then we're going to multiply by something and by something up here and divide by something, and then we're going to multiply by another thing and divide by another thing, and then we're going to, multiply by some third thing and divide by some third thing. We want to have these long strings of calculations so there's not room for error. You want to give yourself the least amount of opportunity to round some answer in the middle of your calculations, because, as hopefully we saw in this example, you could end up getting the wrong answer if you do that. So anyway, thanks so much for watching. In the next video, I'll go over a few more concepts that will definitely be helpful for you to have a good mastery over going into a chemistry class. So anyway, thanks so much for watching, and I'll see you in a future video.